I'm Hannah Bodie.
I'm Sheridan Kate Murray.
I'm Carla Dodds.
And I'm Catherine Ivy.
And we're going to tell you a whale of a tale. So, this tale is the evolution of whales from terrestrial animals to fully aquatic animals, and we do have this long string to show you how big they are, just because they grew from itty bitty to like huge mini buses. So, the first animal that we have is the Indohynus. This is the expansion of the involucrum. The involucrum is in the inner ear, and so basically what it does is by thickening that you can't get as much water into the ear. So when you're going into the water, like you know how when you go swimming you get water in your ear, you just don't want water in your ear. So that's basically what that's doing.
The Indohynus is 2 feet long.
Then you have the transition to salt water. So as they first go into the water, they're in freshwater in lakes and streams, and then they start transitioning to brackish water, and then eventually to salt water. The salt water has more currents and has more tidal waves, and the force in that water is a lot stronger than just in lakes and streams. So the Pakicetus is the next one, and that is the first introduction of the robust tail. So they're getting tails like kangaroos. You know how kangaroos can stand on their tails? They need strong tails with less tail bones because bones are heavy, muscle's heavy too, but muscle can be used to move yourself. So that's why they need a robust tail to deal with the currents and the changing tides and stuff like that. At this point there, if you were to go into the beach, basically as far as you would go in is as far as they're in right now. They're both land and sea, so they do come in and out. They're kind of like a crocodile right now. And then you have the Remington cetus. Well, that's the
Pakicetus is 6 feet long.
The Remington cetus is the lacking of the nasal cavity or organ. So basically that deals with taste and how you can taste stuff as you go through. So when they transition to salt water, they don't need the array of food that they can eat is much larger. So on land, they could only tear up certain things. And so as they go onto the water, they're able to eat much more things. And also salt water doesn't really taste good. And you don't really need to be able to taste salt water as much. So that's the Remington cetus. And the next one is the family of the Protocoeti. This is the Rhodocetus, the Myocetus, and the Amblyocetus. And this is when the neck basically goes back into the body. And now they can't turn their head side to side. They have to turn their entire body. So again, you need a bigger tail. But the thing that the neck does is it eliminates most of those bone structures, and it eliminates the links, so they're not as front heavy, so they're not going to fall into the water. And it makes them lighter and more agile, so they can move quicker and more efficiently through the water.
The Myocetus is 10 feet long. The Rhodocetus is 12 feet long. And the Amblycetus is 14 feet long.
The next one is the Dordan. The Dordan is similar to the modern-day dolphin. The Baleosaurus is the one that comes right after the Dordan, but the Dordan is the first time that you're going to see tail flukes. So what tail flukes do is basically they operate like a rudder would on a boat. So with the tail flukes, if you push one side down, you're going to turn in that way. If you push the other side down, you turn in that way. The other thing that a tail fluke does is because of this V in the middle, it's able to displace much more water than it would if you just had something that was pushing straight down. If you push with two things, it's almost like you have twice the force. There's not huge tail flukes. It's not like a really big V yet, but there is evidence that there is some type of tail fluke as it goes through. The other thing with the Dordan is its hind legs. They don't really need them for flipping because its tail is so strong now. So it pulls its hind legs back into its body. It's got like tiny little flippers, but they don't really do anything, and they just haven't fully gone away yet.
The Dordan is 15.
Okay, so the next group we have is the Ichthyocetus and the Mammalidan. Here in this group we see baby-like teeth, hole in the back of the mouth to filter food. External ears are absent, broad snout, baleen and fur present, sweat glands are absent, and a mobile elbow joint. So up until this point, at this point, all the whales have had baby-like teeth. It's for foods that they eat, such as like crustaceans and things with hard shells, and so the teeth are they're able to crush it. But also we see for the first time the baleen, which is what eventually the next group will fully have, and we'll see the teeth fully eliminated. But researchers didn't think that was possible, but they knew it was because of the filter feet in the back of their mouth, which is the hole. So with or compared to the baby-like teeth, the baleen is basically to help filter the feed. So like in Finding Nemo, whenever you see like the huge whale and he gulps like this huge amount of water and like the krill goes in at the same time. So the baleen helps brush out the food that they eat compared to the water. So it kind of like helps trap the food. And then the external ears, since now they're diving to really deep depths, they don't want holes in the back of or on the sides of their heads because their eardrums would implode, and that would be really bad. And they wouldn't be able to withstand the pressure, and also they have echolocation. And at the same time, they're developing a broader snout for a stronger structure, and their sweat glands are absent because when you're in the water, you don't need sweat glands anymore, so that trait is disappearing. And also an immobile elbow joint, because with an elbow joint, it would be a disadvantage, so without it, it's an advantage to help them swim better and be able to, or just better for their mobility. So the next group that we see is the Cetophrylum, the Amistocetus, and the Melanocetus. We see the telescoping of the skull, which is basically their skull structure just elongating. And then at this point, as I said, we see the full baleen palate, so they no longer have the baby-like teeth. There is separate groups in whales now that are in dolphins that do have baby-like teeth, but the route that we're going have developed full baleen palates. And also we see bowed mandibles, which is like the sides of their jaw is like turning down, and that comes with the baleen palate trait.
Melanocetus is 32 long.
Okay, so then the last group is the Balenoptera. They have fibrous temporomandibular joints, enormous body size, and a ventral throat pouch with grooves. So now that these are baleen whales, as I said, they have to, and with their growing enormous body size, they have to get lots and lots of nutrients. So they have to be able to gulp several gallons of water. So what this pouch does, it just allows them to hold lots of water in their mouth so they can get more food. In general, baleen whales are bigger than whales with baby-like teeth, just because the way that they eat just allows them to be bigger, because with the baby-like teeth, as I said, they're like crunching their food, and they have to like hunt for the food. But with the enormous body size, as I was saying, they have to be able to hold lots and lots of water to get more food. And then the fibrous temporomandibular joint, this goes along with their body size, and so as it's growing and their jaw structure is expanding, they have to be able to have a really strong jaw structure, and so this just is saying that it's strengthening, so it's becoming more fibrous. All this leads to the modern whale.
The modern whale is twice the length of this one.
Okay, so now I'm going to talk about the evidence that supports the theory of evolution that we've just presented to you guys, and also the evidence that supports the different phylogenetic relationships that we showed as far as the traits we've highlighted. So first I'm going to talk about embryology and how that's been used as evidence. So the embryology of hind limbs demonstrates that in earlier embryos of modern cetaceans, the hind limbs are present, but as the embryos continue to develop, they disappear. This is an indicator of land ancestry because it indicates that these vestigial factors were once beneficial but now no longer apply to the whale's current form. Genetic studies pinpoint that the loss of these hind limbs relates to a gene called HAN2, which is actually a regulator of the sonic hedgehog gene that we've learned about. Modern baleen whales initially develop the small baby teeth as an embryo, but they later degenerate and form the full baleen palate. This is another example of the evolutionary pattern from baby teeth to a full baleen palate. Whale fetuses develop vestigial external ears, which is another example of the transition from an outer ear to an inner ear. Although modern whales like hind fins, they still develop their pelvis, which is another example of the evolutionary pattern. So in 1978, a paleontologist by the name of Phil Gingrich found a skull in Pakistan, which was the Pakicetus. This was a really important discovery because the skull resembled the skull of wolf-like carnivores, but it also had some traits in common with the earliest known whales. So the Pakicetus proved to have key transitional features between the terrestrial mammals and whales. Notably, the outer ear was in an intermediate region, so it was transitioning from outer to an inner ear. And then in the early 90s, paleontologists found the first of a series of fossil cetaceans, mostly in Iran and Pakistan, and it documented the transition from land to water. Some fossils retained vestigial hind limbs. Also, some had femurs and tibias, which further represents the process as the whales evolve. While the fossil record is extensive at this point, there's definitely more room for research in terms of evidence of whale evolution. Many of the protocetids are poorly known and understood, and then also some of the main organ systems, such as vision, are not clearly understood yet. However, scientists hope that as they continue to collect information about the fossil record, they'll finally be able to understand the actual hypothesis as to why whales went from land to water.
So now I'm going to talk about the hypothesis. So there's many different hypotheses. To transition from the sea to land and then back to the sea is not something that any other mammal has done that we've seen. Most of them transition to land and then they become the best land animal that they can possibly be, but they don't necessarily go back to the water. So one of the first things that people mentioned is food. So obviously they need more food. They're going to go to this new food source in the water. But some of the earliest whales were aquatic. Even when they were fully land animals, they would go into the water and get their food and come back out, kind of like bears fish in the water, stuff like that. So them necessarily needing to go into the water to get more food isn't necessarily very accurate. It is a possibility because there is so much more food in the sea than on land. But it's just interesting that that's one of the options. Another one of the options is one of the predators. So the land, because most animals transition to land, the land animals have a lot of predators, and so these little wolves and these little hippos can't really run very fast. They're not very good. They get eaten a lot. So we don't want to get eaten. So the way to outrun your predators is to go into the water, because the predators that come either can't swim in the water or can't be very efficient or effective in the water. And so when these land animals transition to the water, they get that tail first. The tail enables them to swim really fast. It makes them really agile. They can turn corners. They can hide. Water, if you shoot at water, the water won't let you go always in a straight line unless you have the strength to overcome that water. So that could be one of the reasons why they go. The other reason is that when you get dolphins from whales, and there's so much diversity in the types of whales and the types of dolphins today, that it's really interesting that they, because dolphins still keep their teeth, and then most whales have transitioned to that fully filter feeding, like a hairbrush kind of combing through their food, which is interesting. So the Dordan is where they do transition off, and the Dordan has that baby teeth, and then the baleen whales automatically, as they transition, lose those teeth. And that's interesting. The nostrils, they can't, okay, so whales are still mammals, so they have to breathe oxygen to breathe, or else they're going to die. And the depths that they dive to, they have a huge lung capacity to be able to hold their breath for more than 2 hours, which I think is pretty amazing. I can't even do 3 minutes. So they're able to dive to extreme depths, withstand extreme pressures, and hold their breath for that long. But they do still need water. So the nostrils on the front, on wolves and hippos and cows and stuff like that, have transitioned to 2 little holes on the top. So one is for water when you filter feed, because you got to get rid of the water. And then one is purely for oxygen, and they don't mix, because they both go the same way, but one's for water and one's for oxygen, so you can't use both, because then you would drown yourself breathing. It just wouldn't work. So they do have 2 holes. I'm sure you've seen whales blow, which I think is
I never knew they had 2 holes.
And so this is our whale of a tail. Whales can dive to extreme depths, and they emit the loudest sound on Earth, reaching over 188 decibels, which would blow your eardrums out. So we don't really want to do that. But this is our whale of a tail.
Only baleen whales have 2
2
holes.
holes?
Yeah.
Which which makes sense because they're filter feeders. Are they side by side or is it one hole with two separate?
I think it looks like they're like separate, but
Two
also like
separate.
pretty
It's like-
close
Like,
together.
yeah, like, it looks like one hole,
Yeah.
but it's,
It kind
okay.
of looks like somebody stuck a nose on top of your head.
It-
I've
Like,
never-
I've
I
seen
didn't
pictures,
know
it
it's
that.
so
actually
weird.
We learned about nutrition class.
They have two holes.
Yeah,
But
it
how-
has the shield
but-
in the front. When it comes up, it
Yeah, but
puts
they
the
can
water
open
on
their
the
mouths
side.
so much and now you're trying to get all that water through a tiny, well, I guess.
It happens really
tiny,
fast.
Right?
Yeah,
Yeah.
there's a lot of pressure, just like.
So that's why they can blow so
Yeah.
high. 'Cause
I guess,
all
yeah.
pressures.
Yeah, because it definitely, like, when you expel it, it definitely intermingles, and that's why it's like, just a lot.
So that's when they're coming, I always thought it was like steam from their breath. Like,
No,
that's the
it's a
water
mixture.
they're injecting?
It's the
It's
water.
carbon dioxide
Outside
is
being
water
so cold,
Yeah,
that's
under
why you
high
can see
pressure.
it.
But that, like the fountain is actually the water they're injecting after feeding.
Plus the like stale
Plus
air
carbon
that you use.
dioxide.
Yeah.
Wow. I didn't know that. That's crazy.
Do you guys have any questions?
Yes, Baxter.
You were talking about how like a big reason they kind of turn to the water is to escape predators. Do y'all like know of any predators that were like that would have been attacking these like?
That's a good question.
40-foot crocodiles.
Well, the predators, not only could there be predators, there also could have been like competition because they were pretty big. But I would think any fast-running land animal that doesn't like the water. So like cats don't like the water. So like big cats would force you into the water.
Yeah, and just size is a big issue too, because I mean, it starts out at 2 feet, so it's
Yeah.
definitely not like something that could hold its own in terms of like even like an average size predator. It would be a little nervous. Did you have, okay, yeah.
I was gonna ask, like, did y'all find any other possible animals that had the same, like, conflicting hypotheses about going from land to water and then again from water to land? Or
We did
vice
find
versa?
that the dolphins, as most of you probably know, there's saltwater and there's freshwater dolphins. So that transition is again a little interesting because nobody really knows why they went from saltwater to freshwater and then back to saltwater. So because if you look on the dolphin evolution, so they transition from freshwater to saltwater, and then half of them transition fully back to freshwater. And again, this would probably be for the same reason. And I just think that it's really interesting that there's so many different ways.
Definitely. The whale evolution is definitely interesting because it was so complete. Like they have really figured out like the macroevolution like really well, but they still like aren't sure like why it happened, I guess. And I think hopefully like with more fossil research, that'll be something that is attainable.
You might have said this. So what part of the earth did they transition to water? Was it like a specific area?
Most of the fossils were found in,
Pakistan and Iran is where they were found.
and if you look at that, the elevation throughout like near the sea, the elevation doesn't go up for a while, and so there were a lot of lakes and rivers, and then the salt water could have come in, and then that's where you get the brackish water transition, and then you go to full salt water.
So they're hippos? They're hippos? Is that what they are?
Okay, so they think that they transitioned from, because they're really kind of unsure,
Yeah.
hippos are the first animals to be able to nurse underwater, to be able to give birth underwater, and eat a lot of their food in the water.
Yeah.
So all whales can nurse and give birth in the water because they're fully aquatic. But then if you look at the size characteristics, if you look at just that part, they're looking at hippos, and then from the hippo is the cow.
Cows, yeah.
But on the other side, if you're just looking at plain body structure, people think they come from like wild dogs and wolves.
Oh, that's
Yeah.
right, yeah.
Wolf size mammals. Because that's what Pachycetus, the skull is like in between wolf size and then like the
So is
early
all the
whales.
stuff fossils, no genetics?
Yeah, the chart right now, well, the embryology is definitely is like the most concrete form as far as like development that we were able to find, just like the vestigial
Mhm.
development. But fossil, there were a ton of fossils that were found. Yeah, and this is the one of Indohyus. It's like one of the most fully developed ones. Yeah, but I think at least right now paleontologists are like going off of the fossils the most, but embryology is like it's developing
Mhm.
as well.
And the other thing that you're having to deal with is up until here and even partway into here, that's 47 million years ago.
Mhm.
And so the fossils that they're finding, they found lots of in-between forms, but they haven't found full fossils in in-between forms. So they're putting the pieces together as they transition from, they find like one piece and they find like one piece later. And then if you put all of those together, then you get the transition.
And like as far as genetic studies, I think the biggest breakthrough was just like the hand-2 gene with Sonic Hedgehog.
Yeah.
Yeah, I think that's probably the biggest that they found so far, so. Okay,